Anyone have questions about query or update calls? I was explaining that this is the main way that you expose your functionality to the outside world. Defining read-only query calls and read-write update calls. Okay, yesterday at the end, we covered everything is going to come, most things, straight out of the Kybra library. These are two decorators. This is just a type. Global variables are persistent. This is a very, very, very important point. This is a global variable. In Python, your global variable is going to be stored on the heap. The internet computer has 4 gigabytes of heap. It's a WASM module, and that's how much heap you get with a WASM module. Once you run out of heap, I don't know what will happen, bad things. So you just have to understand that's the limit. The heap in a canister is different than a heap on your laptop because it's automatically persisted until the canister is, I guess, paused or terminated or something. And you as the, well, whoever, there's a concept called a controller on the internet computer for a canister. A controller is a key pair that has the ability to start a canister, stop a canister, etc. You can remove controllers. You can set the controller to another canister, or you can have multiple controllers. But by default, if you just start up a canister, the heap is just going to be persistent, which is really cool because you can basically build, databases and stuff right on the heap, especially for prototyping. I think it's really nice. So like I said, query calls are very quick. They don't go through consensus. They're fast, but also they're not as secure as an update call because they are going to come from just one node. If you're calling it in something called non-replicated mode, then a default query call is just going to choose the node and return the information. So it might be difficult to trust. Update calls go through the consensus. You need at least 2/3 of nodes to agree. So they are slower, but it's more secure. We've already talked about the dfx.json file. This is basically a bunch of boilerplate, but in the future, we're going to hopefully make it much simpler. Again, here's how you can start up your replica. I recommend just doing dfx start, but dfx start background you can do if you want. dfx deploy will compile and deploy everything. One very, very, very important thing for Kybra in particular, you need to use an unencrypted dfx identity. If you're ever asked for a password by dfx, you need to follow these steps and create a new identity that is not encrypted. It is simply a limitation of Kybra for the moment. It's not ideal, but that's how it is. If you don't do this, you might run into just crazy problems trying to deploy. Like basically Kybra and dfx will use up all the memory on your computer and it'll just be really bad. So just keep this in mind, please. And then we talked about interacting with your canister from the command line and from the web UI. So that's chapter 4, just a basic hello world, very simple. Chapter 5 just goes into more details on deploying. Sometimes you might run into some problems with deploying. For example, if you dfx stop, if you have started your replica in the background, that's how you stop it. Sometimes, also if you're just running in the terminal, you can stop it with Control-C or Command-C, whatever, however you stop processes on your OS. Sometimes, though, you might see something like failed to kill all processes or something indicating that DFX has not been killed. So hopefully it will just give you the process IDs, and you can simply manually kill them if you need to. Hopefully this doesn't happen to you, but if it does, there's information. Also, if something is just weird and going wrong about your deploy, oftentimes if you just tack on -- clean, it's just a good practice. It's going to clean the local DFX information. You'll notice here there's a folder that was created called .dfx, and it has some stuff in it. So -- clean will start that from scratch, more or less. If you want to, so DFX deploy, if you don't add anything after that, it's going to deploy every canister in your dfx.json file. In this case, we only have one, but you might have an application that has multiple. If you have multiple, you can always choose to deploy just one if you want. So in our case, I could say dfx deploy Kybra hello world to ensure that I'm only deploying the Kybra hello world canister. We talked about the command line for interacting. We talked about the web UI. There's also the concept of an agent. An agent is basically your client library. There are agents. There's a JavaScript agent. There's a Python agent. There's a Rust agent. There's a Java agent. The point is that an agent is just that client library that is going to make it relatively simple to interact with the canister. It's going to do all of the, it's going to organize the your HTTP request, sign everything, get everything correct, do all the encoding and decoding and everything. You really want to use an agent. And then here's just some more DFX commands if you need them. DFX build, if you don't want to do the whole deploy process, but you just want to do like the compilation to the WASL binary, you can just do DFX build. If you want to just remove all of the state and code from your canister, you can use uninstall code. When you do want to deploy to mainnet, you need to set yourself up with cycles. You can go to the main documentation to learn how to do that. You need to either purchase ICP, or if there is a cycles faucet that you can use, I believe, to get free cycles. But the point is you need to get cycles. Cycles, again, come from the ICP token. If you have ICP token, you can ask the network to convert that into cycles, and then you basically send cycles into your canisters. When you're ready to deploy to the live network, you just add this little option to the end, and it'll be live, which is pretty nice. And just again, remember, you cannot use an encrypted identity. If you're asked for a password on your DFX operations, you need to stop and create an unencrypted identity, and then you can deploy after that. I just want to point out again the examples directory of the Kybra repository. There's a ton of code that you can already go and look at. Okay, chapter 7 and chapter 8 are just overviews of the internet computer. I did want to show you guys, if you're interested in the topology of the network and a bunch of stats about the network, you can go to dashboard.internetcomputer.org. It's really cool. So you can see all data centers and all the nodes around the world that the network is composed of. And then you can see a bunch of stats. For example, right this moment, there are 5 billion cycles being burned every second, which is pretty cool. And yeah, you can zoom in, go see all that stuff. There are a total of 1,271 node machines. Only 545 of them are actually deployed into subnetworks. There are 10 of these things called boundary nodes. Essentially, they're API proxies that requests will hit before going on into the actual nodes that run the replicas. There are 100 independent node providers, 36 subnets, and there's a bunch more stats that you can look at in here. So the dashboard's pretty fun to look at, FYI. So yeah, we've already talked about the internet computer. If you have any questions, I'm happy to answer them. Canisters, we have talked about a little bit. The canister is the application. Everything we're learning right now is we're doing canister programming. Okay, so let's start making things a little bit more advanced, I suppose. Let's dive into the concept of query method, at least passing over the main points in more depth now. To make a query method, you decorate your method with the query decorator. These are read-only. They're executed on a single mode. They don't go through consensus. Latency is on the order of 100 milliseconds. Remember the instruction limit that I showed you? You have a 5 billion WASM instruction limit. So that's about 1 second worth of compute. And queries are, you're going to have the same resources available to you as in an update call. So you have 4 gigabytes of heap. And you actually have 96 gigabytes of storage in a location called stable storage, which we'll get to later. And a rough estimate of how many queries one canister could handle would probably be about 32,000 per second. So, nothing crazy. So, let's start to flesh this out just a little bit more. Right now, we have a very simple database. It's just a string. Obviously, that's quite limited. So let's try to increase its utility just a little bit. Let's call this database, and let's just make it a dictionary. Cool, it's a dictionary. Let's make a method called set. Let me just make this clean. Check this out. Look at all these squigglies it's giving me, telling me that things are wrong. That is cool. So in this case, we're going to take a key that's a string, and we'll take a value that's also a string. And we can just there we go.
Have you ever wanted?
Okay, so was that a question someone was asking, or was that an accident? All right, we have a very, very simple database right here. It's just a dictionary. Our keys are strings and our values are strings. Also notice we're using a query method. So I'm going to show you the limitations of this. Let's deploy. So what do you think is going to happen after this method executes? Well, we're going to write into the key field, property attribute item, whatever it's called, on this database dictionary. We're going to set that value equal to value. The problem is that because this is a query method, the change is not going to be persistent. So we can write into this all day, and the internet computer is going to discard those changes. So we'll refresh. Nice. I'll just say the key is 0 and the value is 0. Every time I call this, it's just throwing the state away. I can prove it to you by adding an update method to read the state. I'll call it get. You'll just pass a string in, and we will return whatever the value is. So let's return db key. Notice it's giving me an error because it doesn't actually know what the return type is. So, well, I guess, okay, technically, it doesn't have the type information, but we can still deploy because at runtime, it will still work. So that's what's nice about these, TypeScript and Python type systems is they're quite flexible. You can still prototype with them if you know what you're doing. But the goal will be to get rid of all squigglies. Okay, let's try to get a key. This will probably return a major error because nothing exists. Yep. Key error. Oh, also, yeah, that's not what I meant. I meant for this to be a query. It'll work the same though, basically. If I want to set, so I'm going to try to set this, and I'm going to try to get it. Nope, nothing exists there because every time I set, oh, hold on, it's upgraded. Every time I set, it's discarded by the system. Okay, try getting again. Nothing's there. Now let's try setting. Still nothing. Still nothing. Okay. Now let's switch these. We'll make set an update call, and get we'll keep as a query call. And then we should have an actual key value database that actually works, at least with strings. Okay. So let's get key 0, not there this time though, because our set method is an update method. It's going to go through the full consensus, and that change is now persisted on the heap. And we can query it, and look, we have our value. Set another key, key of 1, I have 1. If I query that, it's there. Perfect. Very nice. Let's try to fix these squigglies. So this is just a, look, dictionary unknown, unknown. I think I can just do this. There we go. So now I told it what the dictionary should look like. Pretty cool. So this is just a string. It'd be nice if we could do something a little bit more complicated. Let's add a record. Well, let's introduce the concept of a record. A record is going to be basically your object or your dictionary type on the internet computer. All we do is import record. We make a class that inherits from record. And then you can add your fields. I'll just use int. There we go. So record is a Candid type. Talked about the .did file. It uses the Candid language. A lot of these types that we're using, they have Candid equivalents. String is the equivalent of Candid text. Record is truly a Candid record. Int, the equivalent, would be a Candid int. And there are many more types. For example, NAT64, NAT32. It's only red because I'm not using it. Yes, we do. We have text, bool, things like that. We'll go in depth on all the types later. There we go. So now let's try to get, so there's nothing there. Let's set a user. We'll say that the key is 0. So we'll say the ID is 0. The age is 32. The username is last.js. We'll call that. It's an update call. Goes through consensus. Now we should be able to query this. Boom. There's our record. Pretty cool. Let's say we want to get I don't know, just get all users. We will import the vec type, pass in user, and I'll return db.values. db.values. Oh, db. Is this the wrong? Call it. Hold on. Maybe I'm rusty on my. You guys remember how to get all the guys out of your dictionary? Keys. Values. All right, well, I'm doing the dictionary in a little kind of a strange way. So there's another way to type our dictionary using what's called a typed dictionary. So let's actually make a database that is a typed dictionary. Oops. And I'll actually just make a users table like this. User. Let's see, entry. Yes, that's a simple way that we did it. Okay. Well, I don't know why types are wrong on this. Okay. Point is, you should be able to do something like this. That's the main point. Hopefully that's just a weird typer. Okay. So yeah, I mean, the main point here is we're building things on the heap. We're using native Python data structures. This is just a dictionary, nothing crazy. There is a major limitation, though, of the heap. Beyond the 4 GB limit, The other major limitation you're going to run into is that the heap gets wiped every time the canister code is upgraded. So though your values are going to be persisted across update calls, for example, every time we call set and you call get again, it's persisted. It's always going to be there until you shut the canister down or until you actually update the code. So let me show you that in practice. Notice everything's gone because I've been updating the code. My things are gone. So let me add a user again. Okay, there it is. If I deploy, it's going to wipe. So how do we deal with that? Well, there's a special data type called a stable B-tree map. B-tree map is just a fancy, it's basically just a fancy dictionary. Under the hood, it is actually a B-tree, and it's a map. Map, key value pairs, nothing crazy. We can implement what we just did here using the stable B-tree map, and we'll get the values to work much more easily this time. So we're going to make a variable called users. We're going to say that's a stable B-tree map. And we can give it the same value. What the heck? Oh, yes. That's unfortunate. So first, we're going to type it with the two generic type params. The first is just the type of your keys. The second is the type of your values. Then we're going to actually initialize it. You need to give each of these stable structures a unique memory ID. Unfortunately, IDs 0, 1, and 2 are already used by Kybra under the hood, so you need to start at 3. And then you need to define the maximum key and value size of your keys and your values in bytes. So we're going to say that the keys can be up to size 100 bytes, and the values can be up to size 1000 in bytes. This B-tree map is going to write into a special memory location called stable memory. This gives us up to 96 gigabytes of memory on the latest versions of DFX and the Internet Computer, which is pretty awesome. We're a little bit behind on our DFX. We're on DFX version 0.14.2, so I think it's still at 64 gigabytes, but the point is it's a lot more than 4 gigabytes. Okay, we can now delete our old database. And we can just do this. Users dot get. And we can pass our key in. Now, get actually returns what is called an option or an opt. Basically, an opt is either none or the type that you pass in. This is hearkening to something called an algebraic data type, which is very popular. It's a concept not from Rust, but Rust embraces it. Motoko, the language of the Internet Computer that Divinity created, at least their own proprietary, their own domain-specific language, also embraces this concept. But yeah, for now, just understand it's either none or the type that you pass in. Now, if we want to get all our users, we can say users dot values. That works just fine. And if you want to set something, you'll say users dot insert, pass in the key and the value. Okay. This is probably if you're doing more than just prototyping and you want to make sure that your values persist after every code upgrade, then you'll probably want to use a stable B tree map. And if you need, more than 4 gigabytes of heap space. And basically with what we've covered so far, I mean, you have all the basic building blocks to build all kinds of things. You have a data structure that persists across upgrades with a lot of space. And even if you didn't have that, you can just use dictionaries or whatever things that you want to store on the heap. You can also create arbitrarily complex records. This record, you can keep creating other records and you can nest these. This is just like a dictionary and object. It can be nested and hierarchical. You have all the primitive types that you can just import from here, and natural numbers with certain sizes, etc. And that's basically what your app is, right? You just build all of your data structures, create your database tables, create the methods that you want to expose, and there you go. Okay, now let's try to get all the users. There aren't any. Try to get one user in particular. Notice there's not an error anymore. It just returns null, which is nice. And then if we create a user, it should persist to our stale v2 map. If we ask for all of our users, there they are. And if I ask for user 0, there it is. Now what's awesome about this is if we change our code and deploy, we're not going to lose the information that we put in. So I'll let that deploy. And then I just want to show you chapter 11 real quick. As we were talking about the Candid language and all the types, if you want to see literally all the types, here they are. A lot of these are very self-explanatory. Text, just a string. These are natural numbers, meaning they're positive. These can be negative. These are floats. We have bool, null, vec. Op can be none or the thing. Record is that object type. We didn't talk about variance. We didn't talk about func, service, principles, etc. We can get to those later. But these are all the types that you're going to want to be using for your stable v2 maps and for the parameters and for the return types. Basically, anytime you want the internet computer to encode or decode for you automatically, you want to use these Candid types. And in some places, it's absolutely mandatory. Stable v2 map, it's mandatory. And the parameter signatures, they're mandatory. Okay, if we refresh and we try to get, it should be there. Yay. You notice it persisted across an entire code change. So, I mean, just with up to chapter 12, I mean, these are the absolute fundamentals, the basics, right? Query methods, read only. Update methods, read write. Candid, all the types you can choose from to do your encoding and decoding for you automatically. They're what you use for your method signatures for your stable v2 maps. Stable v2 map is the way to create basically databases that can persist across upgrades. What's left is communicating with other canisters, receiving HTTP requests, and making HTTP requests. Chapter 15 is all about a lot of the APIs that the internet computer provides to you. For example, getting secure randomness, creating new canisters from WASM modules, like automatically. Like your canister could spin up a new canister and deploy something into it. talking about the canister life cycle. You know, the life cycle, the canister gets initialized, a canister gets upgraded, and you can hook methods in to each of those steps if you need to do things. Timers for cron job-like things. Cycles we have talked a little bit about. Caveats, and then of course the reference section is just basically all the APIs available to you. But yeah, I mean, once you're installed and once you've basically made a hello world and gone up to chapter 12, from there it's, I don't know, just reading and learning API after API. So we'll dive in more deeply in the next episodes. So any questions? One question is, why is it that we used global in the update method for the string previously, but not the dictionary? These are just the rules of Python. In Python, yeah, we had a database like this. Yeah, in Python, yeah. It knows because I have not declared any other variable locally, because I'm just accessing it, then it knows that it's global. But if you're assigning, for example, if I was doing this, I would have to, I'd have to say global DB. Otherwise, it would think that I'm creating a new local variable. It's just Python, nothing in a computer specific. Any other questions before we wrap up? Okay, well, I encourage you to just read the Kybra book yourself. No reason why you can't just keep progressing. Go to the dashboard.internetcomputer.org, go to internetcomputer.org. The world of the internet computer is completely open to learn on your own. And it's probably better if you study on your own and bring questions. So that's all I have for today.
Nice. Thank you, Jordan. Yeah, next Friday, we will have the third session. Jennifer Tran, developer relation from the Definitive Foundation, explain us during 10-15 minutes how to deploy dApps, right, directly on the mainnet through Kybra, and how you can use cycles to directly deploy on the internet computer, and we will give you free cycles for that. But anyway, Jennifer, we will explain everything. And yes, please, you have also the Discord channel as well. Any question that you have, please drop in there. And also, yes, I'm sending like emails, weekly emails to do like follow-up about the sessions, also give you more information. Again, for the NFT soulbound token that we have is mandatory, have like be in 5 sessions at least, and also you have to deploy on the mainnet, and you have to follow the Twitter ICP.North to achieve this. Once you achieve all these things, you can receive the soulbound token at the end of the 6 sessions. And yeah, thank you so much, Jordan, for your time. See you next Friday. Yeah, have a good Sunday, everyone, and Saturday for us. See you soon. Bye-bye.
Thank you.